Hi friends, this is Atar Namaskar. Welcome to my YouTube channel Unique Learning Academy. In this video, I am going to explain about Carnot cycle, which is a topic under thermodynamic processes in the thermal engineering branch. So let's get started. Carnot cycle. What is a Carnot cycle now? In this is a Carnot cycle is a ideal cycle, and it is also called as a hypothetical cycle. And it is also called as a theoretical cycle. And this was introduced by a French engineer named as Nicolas Sadi Carnot in the year 1824. Named after this, so the reason Carnot was named after this scientist itself. Next, what is the working medium? Here the working medium is it receives heat at higher temperature. It receives heat at higher temperature and rejects heat at lower temperature. So Carnot cycle is represented as a standard of perfection. Next, Carnot cycle is represented as Carnot cycle is represented as a standard of perfection and engine can be compared with it to judge the degree of perfection. And this cycle is a reversible cycle. And coming to the process, there are two isothermal processes two isothermal processes and two reversible adiabatic processes. Two reversible adiabatic processes are there. So now this is what about the Carnot cycle basics. So let us recall the things once. It is an ideal cycle, hypothetical cycle, theoretical cycle, and introduced by a French engineer named as Nicolas Sadi Carnot in the year 1824. So this cycle was named after the name of an engineer as Carnot cycle. Now coming to the working media, receives heat at a higher temperature and rejects heat at lower temperature. This we need to remember. And the next term is Carnot cycle. It acts as a basis to other cycles, and in this coming to the processes, there are processes as two isothermal processes and two reversible adiabatic process. Now it gives a maximum efficiency. It provide maximum efficiency compared to all other cycles. So that is the reason we call it as a ideal, hypothetical and theoretical cycle. Now this is what about the cycle. Now coming to the now let us go with the PV and TS diagram. Now here, as we said that there are processes are two isothermal processes and two reversible adiabatic process. Two isothermal processes are, one is isothermal expansion and the other one is isothermal compression, and the next two processes are a reversible adiabatic process. This reversible adiabatic process is also called as isentropic processes, and the remaining two are the isentropic expansion, or else we call it as a reversible adiabatic process. And the second process is isentropic compression. So here there are four processes, that are two isothermal processes and two reversible adiabatic process, or also we call it as isentropic processes: isothermal expansion and isothermal compression, isentropic expansion, isentropic compression. This is what the PV diagram. So these are the four processes. Now let us go through the PV diagram, and volume is plotted to the horizontal line and the pressure is plotted to the vertical line. Here now this what indicates that temperature T1 is equals to T2. Here this is what the temperature line. Here to draw this PV diagram, to plot this PV diagram, we need to have two parallel curves of isothermal lines and two parallel curves which need to intersect the parallel curves which has drawn isothermal, and that intersector point we named as 1, 2, 3 and 4th point, and this line indicates that constant temperature line. So T1 is equals to T2. Here this line indicates that constant temperature T3 or T4 is equals to T3, and this line indicates that S1 is equals to S2 and entropy. Here S4 is equals to S1, and here indicates that S2 is equals to S3, right? And now here what is that PV diagram in this is, here 1 to 2 it is the isothermal expansion. What happens in the isothermal expansion in this is the heat is fully absorbed by the air. The heat in this process, the heat is going to be added by the system, heat is added and it is absorbed by the air, and whatever the heat is given to the system, it is utilized in doing the external work. That is what the thing which is going to happen in the isothermal expansion. And next process is isentropic expansion. What happens in the isentropic expansion in this is there is no heat is going to be observed, or no heat is going to rejected by the air. There will be no heat addition or no heat rejection. That process is going to happen in the isentropic expansion. So because of the addition will not be there as well as rejection will not be there, so there will be a decrease in the internal energy. So this decrease in internal energy will leads to the work done by the air during the adiabatic expansion or an isentropic expansion. This was be carried out in this process. And next process is isothermal compression. What happens in isothermal compression in this is the heat is rejected and is equal to the work done on the air. Here heat will be rejected. So when heat is rejected, then what happens? Work is done on the air, not by the air but on the air during isothermal compression. But here one thing we need to remember and note is that the expansion and the compression ratio must be equal. Expansion and compression ratio must be equal. That we will be seeing in just in a couple of minutes what is a compression ratio. Otherwise the cycle will not be remains to close. So we need to remember that point, and it is an important thing which we need to note and remember. And during this fourth process, then next coming to this fourth process, isentropic compression, what happens in this is no heat is observed, or it is neither heat is going to be rejected. So what happen in this is increase in internal energy is going to be done. When increase in internal energy, this is going to be done not by but on the air during adiabatic compression. That thing it is going to happen in isentropic compression. So this is what about the PV diagram. So now let us let us go in the deep now. When we go into the deep now, what happens? Let us see. When here at point 1 to 2, what happens in the cess? The pressure is going to be decreased. It is what the constant, at the constant temperature pressure is going to be decreased, and at the in the second process the pressure is going to be pressure is going to be decreased, and the volume is going to be increased. That we will be noticing. And in the third process, what is going to happen in this is here the volume is going to be increased. And in the fourth process the pressure is going to be increased. These things we are noting in the PV diagram. And in similar way here in this, what happens in this is this line we call it as C, this line we call it as S1, and this is what the S2 and S2 are the entropies, and this is what T1 and T2 are the temperature. Here at the constant temperature, what happens in this is in the constant temperature entropy is going to be increased. When we plot the temperature versus entropy, so these itself we call it as TS diagram, and entropy is represented as S. When now if we go in depth, so what is there in this is T, this is what the temperature line, and this is what the entropy line. Here when in the first cycle 1 to 2 process, in the first process 1 to 2, what happened in this is in this TS diagram temperature will be constant but entropy is going to be increased. In the second process, that is isentropic expansion, here the temperature is going to be reduced, and entropy is going to be constant. And in the third process, isothermal compression, what happened in this is the temperature will be constant and entropy is going to be reduced. And in the fourth process, isentropic compression, temperature is going to be increased whereas isentropic will be constant. So this is about the PV diagram, and this is what about the TS diagram. If you find my video is helpful for you, you can like, share, subscribe and comment on my YouTube channel, and don't forget to share it. To subscribe my YouTube channel, press bell icon for latest videos.